Hello and welcome to this BioProcess International Ask the Expert webcast. I'm your host, Leah Rosen, online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Tony Foltz from Fujifilm Diosynth Biotechnologies.
Thank you, Leah. Good morning, everyone. As Leah said, my name is Tony Foltz. I first want to thank everyone for taking time out to attend this presentation on proper task performance. I'm the Director of Upstream Manufacturing for Fujifilm Diosynth Biotechnologies. I'm responsible for the upstream cell culture, fermentation, and recovery areas. For those of you not familiar with Fujifilm Diosynth Biotechnology, we're a contract manufacturing organization with over 20 years of experience to include 3 sites and 1,200 employees. We have experience with over 300 molecules and have 6 licenses for commercial manufacturing. To date, we have completed over 2,000 cell culture and fermentation GMP batches. Our objectives for today start with me boring you with an introduction to talk about myself a little bit. I will then discuss the background or need to improve human performance. I'll talk about our new human performance method for task execution, including how we sustain it. I will then talk about the effectiveness of this new method and then wrap up with the conclusion. Last but not least, I will open up the floor for questions. So introduction, a little bit about myself. I'm a veteran of over 12 years in the Navy, where I spent time on submarines as a nuclear trained mechanic. Shortly after leaving the Navy, I started at Diosynth as a floor technician in fermentation, where I spent 10 years before going to work for Duke Energy at the Sharon Harris nuclear site. I returned to Diosynth in 2015 as a senior engineer, then transitioned into my current role. In the interest of human error reduction, I joined the BPOG Human Performance Team earlier this year. So why are we here today? We're here to talk a little bit about human error reduction. It was responsible for approximately 75% of our batch failures last year. As you can tell from the opening slides, our technicians operate in a very dynamic and stressful environment. These are some of the contributing factors to human error. Because we have multiple projects running concurrently, our technicians may be involved in the execution of several processes during their shift. I also want to throw in a disclaimer here. This presentation does not discuss how we determine the root cause to be human error. This can be another presentation in itself, as methods to determine root cause vary from company to company, so please do not focus too much on the number. The goal of this presentation is to discuss the method we use to reduce that number, regardless of what that number is. Why do we want to reduce human error? Is it for metrics or KPIs, profits or bonuses? While those are very important to our organization, it is not the most significant reason. The reason we want to reduce human error is people. They depend on the life-enhancing and life-saving drug products that we produce here. Batch failures can prevent patients from getting these life-enhancing and life-saving drugs. These patients are counting on us to get it right the first time. How to reduce human error at Diosynth? We have several ways we are doing this. We utilize human performance tools that we'll discuss a little later that can be found most anywhere, although we did tweak them a little bit to fit our facility. We also have a certification program that is heavily dependent on theory-based training. If we understand why, the how is easier. This also aids in troubleshooting when issues arise. We implemented a more robust method of task performance to reduce errors, which is the core of this presentation. This video training was delivered to all of manufacturing, part of our quality group, and to our manufacturing technology and support group. While manufacturing evaluates and monitors our human performance program, we extended that to other parts of the organization that are on the manufacturing floor. Quality and manufacturing technology and support were included in this training so that they are aware of the expectations during execution. We also know that improved procedures and engineering solutions will help to reduce human error. It is our job to provide these necessary tools to our technicians to ensure that they are successful. So human performance tools, these are common, used to reduce error that we have posted at all of our shift boards. As I said, you can find these most anywhere. During my time in the nuclear industry, I became very familiar with the use of human performance tools and how they directly contribute to human error reduction. They are a non-negotiable requirement for every single person performing tasks at the site. It is embedded in the culture for employees and contractors alike. The site was expected to have less than 20 human error-related events in a year. This includes the plant shutdowns that have over 1,500 people on site every day, including contractors. This amounts to over 18,000 man-hours per day, most of those days with no human errors. It was not uncommon to go through an 8-week outage of 18,000 man-hours a day with 0 human errors. Why am I discussing the nuclear industry? Well, if you live in the Raleigh area, you have a vested interest in human error reduction at the site. It is also to demonstrate that the methods they utilize work. They use human performance tools in a very robust and consistent manner to perform tasks. So I stole that with passion. Certification. While this is not the core of our presentation, it is worth mentioning. As discussed earlier, our certification program includes theory training to ensure our technicians understand how things work, both for processes and equipment. It is not limited to theory training, as task performance also plays a big part. As you can see, there are several core and functional areas included in the program. Levels include qualified, certified, and SME, which is subject matter expert. Pardon the pun, but knowledge is power. This increased knowledge, as well as operational proficiency, improves our execution as well as the ability to troubleshoot problems. So the focus of the presentation, proper task performance, is a 3-step process that utilizes the human performance tools discussed earlier. It is broken down to the 3 areas are discuss it, do it, and review it, all of which we will discuss in more detail. This method is essentially a task with a pre- and post-job brief. The first step is discuss it. This step ensures both people are on the same page by identifying their roles, and it ensures they have the same understanding of what the step requires prior to execution. If both people are not in agreement, or there are any questions about the task, stop and escalate to area management immediately. Deviations have occurred because the performer and the witness were not aligned on the step requirements. This discussion should be tailored to the task. If you're setting up a bioreactor or fermenter, or performing an inoculation, the discussion will be more in-depth than performing a simple task such as sampling. The important thing is to discuss what you're getting ready to do. The next part is do it. That is the task execution itself. Communication is the key for this part of the process. Verbalize all actions with particular focus on values and unit of measure. There's a big difference between grams and milligrams when weighing raw materials. Your batch will be impacted if a raw material is off by a factor of 1,000. During the execution of the step, the performer is waiting on acknowledgement or agreement from the witness prior to taking the action. This acknowledgement from the witness should also include values and unit of measure. If I'm setting a pump speed to 65%, I want to hear the witness agree with the setting of 65% before I do it, then verify that I've set it to 65% after I do it. This keeps both people focused on the task, and it leaves no doubt that the correct action was taken. It is also important to note that the verbalization can be used when working alone. This can be a little bit of a hard sell because most folks don't want to be seen talking to themselves. Again, referring back to the nuclear industry, this is very effective. And if we all think about it, we've done it. We've all said something that as soon as it came out of our mouth, we just didn't think it sounded right. This is the same concept here, and again, it does work. Review it. This is the last step of the process. This basically is asking, was the step executed properly? Did we do what we said we're going to do? If the answer is yes, the performer and the witness will sign the step. If the step was not performed correctly or you did not get the results you expected, then you would immediately escalate to area management. I will tell you that this is the step that gets missed the most. In my opinion, human nature is to complete a task and then move on to the next one. This step may not prevent an error, but it should detect one in a more timely manner. Sustainment. As with any change, sustainment is important. We use visual aids, and we make it part of our shift turnover to ensure it's discussed frequently. Our shifts even provide examples of how DDR was used or how it prevented an error. Observations and monitoring will also help ensure this happens. And again, this is why we included other groups in the training to ensure they know the expectations of this method and what to look for with in manufacturing. The feedback we've received from quality and manufacturing technology and support has been instrumental in the successful implementation of the DDR method. What makes this difficult is this is a culture change. And because it is our nature to resist change, we must keep it at the forefront at all times. For those of us old enough to remember when seatbelts became law, you can remember people saying, I don't need a seatbelt because I'm a safe driver. It's a little bit of the same concept here. Folks have been doing things the same way for a long time, and some of those folks have done it very well with little to no errors. So changing the way people are to approach task execution has been challenging and is challenging, but must be embraced by everyone for it to be successful. Has it been effective? The short answer is yes. Year to date, we're 65% deviation reduction, which is very good. Observations and audits have been very positive, and client feedback has also been very good. While they're not necessarily familiar with our DDR method, they comment on the level of communication and assurance our technicians display when performing tasks. That last part of the bullet there, interviews, is also very important, without exception. For me in particular, at least, every human error related issue we've had this year determined some or all of this method was not used. In the interest of continued improvement, we're also tracking these issues to identify what part or parts of the DDR method was not used and the corrections to prevent future occurrence. This will help identify specific issues or gaps that need to be closed. So while it is a very useful method, we do want to look at the things that get missed and see how we can improve and close the gaps on those. So the conclusion, human error, in my opinion, will always be the biggest contributor to deviations or failures, regardless of industry. We can and should always improve procedures, provide engineering solutions, and training to our technicians. However, mistakes will still be made because people are fallible. I'm also very confident that if we're diligent in our use of our new DDR system, we can significantly reduce human error and therefore deviations and subsequent batch failures.
Thanks, Tony.
Yeah.
So for the first question, how much time does the DDR method add to the performance of a task?
In average, the DDR method is going to add approximately 15 to 20, 25% to the task, depending on the complexity of the task, of course. As I said earlier, if we're discussing taking a sample, that can be a fairly short operation. If I'm discussing an inoculation, for instance, that's a longer discussion. 15 to 25% in my experience is a pretty good average. What I do tell the technicians, or when I'm providing this training, because people do get concerned with this is slowing me down, I'm not going to be able to get as much done, what I always tell them is that we always have time to do it again. So I'd rather slow down and cost 15 to 20% of my time and get it right the first time.
Okay. And another question, you listed 11 human performance tools and stated you require use of the tools for every activity. Are you requiring use of all 11 tools every time or just DDR?
That is a good question. We do have the human performance tools that list those 11. Those are posted, and we ask that they implement those all the time, as many as possible when they're applicable. The DDR method, though, if you look at and break it down, it includes most of those 11 tools. Now, there's 2-minute rule for safety and things like that aren't necessarily part of the DDR method, but the method itself will include, if you're using the method, you will check the box on most of those human performance tools.
Okay. And how many areas are involved in this across Fujifilm BioSynth?
Right now, this is manufacturing. We've kind of piloted the program, but we are looking at implementation in other areas that also have performers and witnesses. Quality control, sampling, things like that may be next. But for right now, it's just been in manufacturing.
And do you have any idea how much FTE it would add if you need a witness for key steps?
I'm not sure I can answer that because we have that. The focus there is to identify what the critical steps are. Those are the ones that require the witness by execution. So I don't know. I don't know that I'm prepared to tell you this week to do it with this many less FTEs, but we do require all of our critical steps to be witnessed, and then we also have some steps that are reviewed by or checked by. But this centers mostly around of course, the witness by for the critical steps.
And with the review section of DDR, do you implement both concurrent and independent verification in all cases, or just use one or the other?
It'll typically be one or the other. Our witness, of course, is concurrent verification, must be witnessed at the time of the execution, where independent is our checked by, which can be done at a later point. We do utilize both in most of our records. And again, the witness by or the concurrent is going to be for critical steps. So we don't require them both. We require one or the other.
Okay. And when the operator is reading out the instruction to the witness, does the witness rely on verbal instruction, or are they also required to read the instruction themselves?
They should absolutely also be reading the instruction themselves. That is a good question. In the case of implementing both, approximately how many bypass one of the first verification methods and is caught in the second? So I guess the concurrent and independent verification. In the case when you're implementing both, how many bypass the first verification is caught by the second, in your experience? I could not put a number behind that. Where we will typically catch that, again, we will either require one or the other, either a witness by or a checked by, which is the concurrent and the independent, respectively. Typically, when those issues get caught, they're reviewed again by another party as a manufacturing review or a quality review at the end. That's what makes this system very important on the review part at the end. Is by then, by the time a reviewer catches it, it's probably too late. We want those to be caught immediately. Again, the review part may not prevent the error, but it will catch it immediately. That is the purpose of the review part.
And
Did I answer
is the reviewer independent, or I think so. Is the reviewer independent or one of the two operators?
The reviewer should be independent, but the manufacturing review part typically happens after the fact. The execution of the step, there is not a requirement to review it immediately after execution. That is the purpose of the witness by or checked by, is to make sure that that step was performed correctly.
Okay. Well, I think that's all the questions we have for now. Thank you, Tony.
You're welcome.
And thanks to our audience.
I do want to, Lee, I would like to take the opportunity and thank everybody for attending the presentation. I hope you did get something out of it, and I am absolutely open to any comments or suggestions to improve our system here, or I can answer any further questions you may have. My contact information was on the first slide or two. Either way, please feel free to contact me, and thank you again. I enjoyed it.
Thanks, Tony. So the recorded version of this webcast will be made available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link, and we'll also include Tony's email in that follow-up. We look forward to having you join us at our future BioProcess International Ask the Expert webcasts. Look for those announcements in your inbox. Thanks.